But so shape, outlier, center, spread. And so we've talked about shape, we've talked about center and all the different ways we talk about that. Outliers, we talked about that way to calculate it, and we have spread. And so exactly what we're doing right now with our social distancing is we're trying to spread out the curve. We're trying to spread it out, and so that we can handle our healthcare system capacity. And so really, I mean, that's what we're looking at. These have very different spreads. The total is the same. And so that's what we're going to talk about today. And so, oops, I need to go to my different presentation, which is up here. Here we go. So, 3 measures of spread. Standard deviation is the new one for today. So, pick the graph that doesn't belong. You take a look at these 4 graphs. We have our dot plot in the top right. You have your histogram in the bottom right. You have another version of a curve, and then you have your box and whisker plot. As you take a look, what we're talking about, what's different about them is the fact that the largest range is going to be here from 18 to 20, without a doubt. And so this is kind of all condensed, and that's condensed over here from 18 to 20 as well. So with the one on the top right, if you have this dot at 18 and you have a dot at 19, that's a different range. Here with this histogram, you might say, well, doesn't that have a range of 18 to 20? But you're not guaranteed that you have a actual dot or a data point at 18 nor at 20 with our histogram. Remember how we round down and round up? And so that's why you can't be sure that the spread is 1820, except for with your box and whisker plot. So it's a different way to think about spread. Range can be used to determine spread. It's the minimum to the maximum. And so obviously, if you have a smaller range from 18 to 19, you know where your data points are going to be versus 18 to 100. And so that's a way to measure that spread. We talked about interquartile range. That's that box in your box and whisker plot. Remember, it's 50% of that data is in that center region. And so these are the 2 box and whisker plots for those particular graphs that you have there. And standard deviation is the next one. And so the larger the standard deviation, so what that means is your middle of your graph, that's like where your mean or your average is, as it states here. We talk about the number of standard deviations you are either above or below your mean, your average. So apparently this standard deviation is 0.25, whereas the one on the right, the standard deviation is 23.7. And so obviously 23.7 is much bigger, and so it's got a bigger spread. And so the smaller the standard deviation, the smaller the spread of the data is going to be. And so we get into more specifics of standard deviation as we look at percentages of the whole thing. And that's what this part says here, is that in a normal curve, which is what these are, that's like, yeah, a normal curve. What you have here is within 1 standard deviation above and below is always going to be 68% of the data, always, right? So in every single problem, if it's a normal curve, within 1 standard deviation above or below, you'll always have 68% of the data. And so that tells you, I mean, that's a bulk, right? I mean, that's just over, it's over 50%. Most of your data is within that 1 standard deviation above and below. I'll let you guys watch these videos. These are embedded in the lesson, but you can have a better idea if you watch this video or that next video and how to calculate it, right? I'm not going to go into those details in this conference just because, you know, those videos are available to you elsewhere. And so this is really the important picture for when we're talking about standard deviation. When you have a normal curve, a normal distribution, which as far as our shape is concerned, remember that's your first S, that's when you have a symmetrical curve, or it is symmetrical. Normal has a lot more to do with it, but that's not our concern right now. So within 1 standard deviation, so this is a Greek letter sigma. So 1 standard deviation above or 1 standard deviation below, 68% of the data sit here. So you can see that's divided in half. So 34.1, actually 68.2, but 34.1, 34.1. You have another 13.6 in this yellow region, and you have another 2.1% in that red region. So within 3 standard deviations of your mean, you have 99.7% of your data points. Why that's important to you as a statistician is like if something happens to be 4 standard deviations, or we actually say like 4.2 standard deviations above or below, that's like a crazy outlier, you know, to be that far below or that far above. That's a crazy outlier to be that far. And we also measure things that way and say, okay, well, you know, if the average height, I'm just making this up, I have no idea what the average height is. If the average height is 5'11", it's probably a little tall, but we'll just say the average height is 5'11", and someone is 6'2", it's like, okay, well, that's 3 inches higher than the average, so they are, you know, perhaps 0.8 standard deviations above the mean. It's like, okay, that tells you that, you know, where you rank amongst all of the other data points. So this is the Greek letter sigma. Mean is mu, x bar is your average. This is how it's calculated. We do not expect you to be able to do all these calculations, right? We don't want you to have to do all those calculations, but that's what you're supposed to be able to do. I mean, if you're doing all these calculations, you have all this stuff, you have your data, you find the difference, so the distance, the difference between your data point and the average, and then you square it, and then you average it, and then you square root it. That's all, right? Super simple, especially when you have like 100 data points, right? No, that's crazy. But I mean, that's the actual calculation that you do. And so what we really care about is this percentile stuff over on the right side, because when it comes time for you to calculate the standard deviation, you will be using your calculator to do so, right? And so now I'll show you how to do that in just a moment. But these percentiles are what most of your questions, or many of your questions, are going to be about. You know, say if something is 1 standard deviation above, you know, what percentile is it in? Okay, well, 1 standard deviation above, if I'm trying to highlight it with my cursor up here, that's actually the 84th percentile, right? Because 1 standard deviation is at the right side of this green section. So the middle is 50%, right? You have 50% below, 50% above, right? So middle is 50% and another 34%, right? And so that's why that percentile is, that percentile is 84%. If you're 1 standard deviation below, so that's minus 1 standard deviation, you're actually at the 16th percentile. That's a big change, right, for above or below. But that's because you are 34% less than the middle, right? So I mean, that's why this image here, oh gosh, I wish I could point to things like I can in the classroom. But that's why this image here is important, because you have your, you know, red region, that's 2.1 percentile. You have your 13th percentile, you have your 30, scratch that, you have the 15th percentile, 16th. And then you have your 50th percentile, 84th percentile, 97.5 percentile, and then 99.85 percentile. So I know that's a lot of percentiles I just threw at you, but that's why this image is so important when you're doing those questions. Questions could ask you about either what is the standard deviation above or below, or they'll say the mean is 10 and this data point is at 8 or something like that. And that will happen to be at a nice standard deviation amount. So you'll have to take a look at that in your homework. I just want to show you real quick. Let's see if I can get this to work. So I'm going to take my picture and it should turn into, let's see if I can get this to work right. One second, almost. So I'm going to take my picture and turn it into my document camera. So now you should see my document camera here. And so remember, as you're doing your work here, you use your stat list. So you use your stat button. And so try to get a little more light on the subject here. So you have, and then you're going to edit your list. I already have some data points entered in here. Remember, you can arrow up and clear all that stuff out, but you have all that data that you enter. You're going to hit quit, and then you hit stat again. Move over to the right to calculate, You guys able to see this? Is the lag time okay? Or are you able to see it? You're able to see it enough? Okay. And you're going to calculate your one variable stats. So when you hit enter, you're just going to go down and calculate that. And you have your one variable stats that we saw earlier. And if you arrow down, you have your 5-number summary for your box and whisker plot. But if you arrow up, you have these two important pieces of information. You have the SX and you have sigma X. And this one important key for the homework is that those are your standard deviations, right? So the sigma is your population standard deviation. And I don't know if this was in the presentation. I skipped it or what. The S is the sample standard deviation, right? So you have your population standard deviation of sigma. You have S, which is your sample standard deviation. You notice those are slightly different. And that's a stats thing where if you have the entire population, so you have everybody that's possible in the entire group, then you know that exactly all the data points. But if you only have a sample of the standard deviation, there's some data points that you don't know. And so that's why we allow for a little extra, variance, a little extra spread in the whole thing when you're doing that. And so that is important for you to remember as you're doing that work. And so the questions online will say, they will say whether this is a population standard deviation or is a sample standard deviation, right? So you have to make sure to read that carefully so that you know which one it's actually talking about. So I should be back here. So with that, that kind of concludes the STAT.5. Yes, that stuff is all in the it's all in the lesson. It's all in the My Open Math. And so as I stop recording here,